To tell if something's a linear function, it's going to make a perfectly straight line. So we could take these ordered pairs and graph them and see if they connect in a straight line, or we could just see if they're all the same spaces apart. So we look at how far apart they are on the x-axis. So we figure out that change. From -1 to 2, that's forward 3. From 2 to 5, that's forward 3. And from 5 to 8, that's forward 3. The changes in the x are all the same. Now we need to see if the changes in the y's are all the same. From 0 to 1, that would be up 1. From 1 to 3, that'd be up 2. And from 3 to 6, that'd be up 3. So that means that it keeps getting taller and taller. So it would not connect in a straight line, and this would be a no. When we look at these ordered pairs, first we'll look at the differences in the x. So we'll look between 0 and 2, that's forward 2. From 2 to 4, that's forward 2. And from 4 to 6, that's also forward 2. Great. Now let's look at the y's. From 2 to -1, that's backwards 3. From -1 to -4, that's also back 3. And from -4 to -7, that's back 3. So those are all evenly spaced out, so this would, yes, make a perfectly straight line and be a linear function. It is important to point out that the numbers that the x's change by and the y's change by, they don't have to be the same as each other, but this number, this number, this number, they all need to be the same. So like +2, +2, +2, and all these numbers need to be the same. Graphing when you are given the slope, remember the slope is m, and the point, that's where we go on the graph, the x comma y. So we're going to go 1 over on the x and 1 up on the y. So we'll put a dot right there, and now we'll count the numbers for the slope. Since 2 is on top and it's positive, it means we'll go up 2. And since 3 is on bottom and it's positive, we will go to the right 3. So from the dot we made, we count up 2 and to the right 3. Put a dot. I'm going to do the same thing but go the other way. I'm going to go down 2 and backwards 3. And that way I can make a line right through those points. To do the next one, the slope is -1 over 3, and the point it's going to pass through is -2, 3. So first I'll go back 2 and up 3. So there's my first dot. Now we'll count the slope. When you have a negative slope, you can choose. I'm going to make the negative sign go with the 1. So -1. That means I'll go down 1, and I'll keep the 3 positive, so I'll go to the right 3. So from my dot, I'll go down 1 and right 3. There's a dot, down 1 and right 3. And connect those. In order to graph using intercepts, first we're going to find the x-intercept, which means we're going to plug in 0 for y. When we do that, we get 2x minus 3 times 0 equals 12. Well, 3 times 0 is just 0, so as far as we're concerned, that all cancels out, and our job is to solve 2x equals 12. When we divide both sides by 2, we get x equals 6, and our x-intercept will be at 6 over 0 up, if we just plug the 6 in right there. So we'll put a dot on the x-axis right there. To solve for the y-intercept, we'll plug in 0 for x and figure out what y is. So we'll solve 2 times 0, we're plugging in 0 for x right there, minus 3y equals 12. 2 times 0 is 0, so that cancels out, and we're left with negative 3y equals 12. So we'll divide both sides by negative 3, and we get y equals negative 4. So the y-intercept is 0, negative 4. So we go 0 over and 4 down. Now we connect the x-intercept and the y-intercept with a line. So to get the x-intercept on this one, we'll plug in 0 for y, which basically means that that cancels out. Sometimes we call this the cover-up method because you can just ignore whatever's in front of the y and solve the remainder of the equation. So we'll have 6x equals negative 24. Divide both sides by 6, and we get x equals negative 4. So the x-intercept, when we put that negative 4 right there, will be negative 4, 0. So we'll go backwards 4, 0 up. Next we'll do the y-intercept, which means that we will be plugging in 0 in for x, and essentially we will be just scribbling that part out. So the equation we'll be left with is negative 2y equals negative 24. Notice I just scribbled out the 2x. I didn't scribble out the sign in front of the 2y because that goes with the 2y. So we'll solve that by dividing both sides by negative 2, and we get y equals positive 12. So the y-intercept, when we put the 12 right there, is 0, 12. So that means we'll go 0 over and 12 up. And that would be way up high, 6, 7, 8, 9, 10, 11, 12. It'd be way up high, way up here. If you need to adjust your graphs to fit, that's fine. But it'll be steep like that. We already learned how to graph equations in slope-intercept form. M is the slope and B is the y-intercept. If you notice, the equation is solved for y equals. So to solve something like this, we just need to make it so that the y is all by itself. So what we need to do is get rid of the positive 3x by subtracting 3x right here and subtracting 3x from the other side. Then we'll have the y all by itself. In order to make it look exactly like slope-intercept form, we should put the negative 3x first, and then that 5 is positive, so we'll put plus 5 after it. Now we can graph it. First, we'll go to the y-intercept, which is positive 5, put a dot. Then we look at the slope. It's the number in front of the x, so it's right here. Negative 3, it's over 1. So the negative means we'll go down 3, and the 1 means we'll go to the right 3. So from the y-intercept, we go down 3 and to the right 1. Down 3 to the right 1. And then you can connect those dots. In order to get this equation having the y all by itself, first we need to get rid of the plus 30. So we will minus 30 and minus 30. 5x and 30 are not like terms, but I will write the 5x first and the minus 30 second, and that all equals 15y. We almost have y all by itself. We have to get rid of the 15 that's being multiplied by. So we divide by 15, and we divide everything on the other side by 15 as well, underneath the 5x and underneath the 30. Now it's just a matter of simplifying. We can simplify 5 over 15 if we divide the top and bottom both by 5. That will come out to 1/3. So we'll have 1/3 x, and then when we simplify the negative 30 over 15, that becomes negative 2, and that equals y. If you prefer to write the y equals first and then the 1/3 x, minus 2, that's all right as well. We'll go to the y-intercept, down 2, put a dot, and then we'll count the slope. This is a positive 1 on top, so we'll go up 1. That's a positive 3 on the bottom, so we'll go to the right 3. So from the y-intercept, we'll go up 1 and to the right 3. And then connect it with a line. To graph the line x equals 2, you look at the x-axis, go over 2, and you make your line so that it shows everywhere that you're to the right 2, which would be this vertical line right there. To graph y equals 5, you want everything that is up 5. So we go to the y-axis, put a dot on 5, and everything at that level is up 5. That's it.